Good afternoon, my fabulous chemistry students. Video number 7 and the last video of this unit. Woohoo! Colligative properties. We need to understand that the properties of solutions will change when I add solute, specifically our melting point and our freezing point. Okay, so we'll understand now why do I salt the roads, salt being added to water, snow, or ice will change the normal freezing point of that water, hence making it look like it melted. This will be the property that helps us get through our last lab, which is making ice cream. Colligative properties for electrolytes based on the number of particles. An electrolyte is a substance that produces ions when dissolved in solution. Because they are free to move around, we call them mobile, and they conduct electricity. So that's that when I put an ionic solution into or ionic solid into solution. Remember, we had the light bulbs to light up in a different lab, right? Property of an ionic solution. Okay, same concepts as the mobile electrons in metals once I'm in solution because they are free to move. When a solute is dissolved in a solvent, the solvent molecules surround these particles of solute. This causes the boiling point and freezing point of the solution to change in a very specific and predictable way. So, boiling point elevation is elevation increases when solute is added. So if I add salt to water, it allows me to cook water now at 102 or 103 rather than 100 degrees Celsius, which is the normal boiling point of water. It's been elevated, and hence the pasta will cook faster. Freezing point depression decreases. The freezing point decreases when a solute is added. So if I take salt and I put it on the roads, that makes ice melt below 0 degrees, probably -2, -3, okay, is where I can get the temperature to go before it refreezes again, okay, because it'll melt at 0. The only thing that's difficult to understand about this particular topic is freezing point depression and boiling point elevation happen at the same time. So if I add salt to water, instantly the boiling point of the water and the freezing point of the water changes. The problem with that is, as I get towards boiling, I'm at the boiling point. I can't measure the freezing point. You see what I'm saying? But let's say the water's at 50 degrees. If I put salt in the water, that saltwater solution now, the water will not freeze at 0 anymore. It will also not boil at 100 anymore simultaneously at the same time. But I can only test one at a time because of the temperature. Okay? So, ionic versus molecular solutes. Why do we salt the roads in the wintertime and not sugar them? Well, let's kind of get into this. So, the reaction when solute is dissolved in water. Does it dissolve? Yes. Why am I not writing? Go to my smartboard. There it is. Dissolves. If I take salt and put it into water, it dissolves, but it also dissociates. So that means it splits up into Na pluses and Cl minuses. Here, it's still just C12H22O11, but it will dissolve into packets of that, where this dissociates into 2 packets. You see how it's 2 to 1? So the number of moles of products produced, well, here I'll get 1 mole into solution if I started with 1 mole. If I start with 1 mole of NaCl, I will end up with 2 moles of solution because I'll end up with a mole of Na now and a mole of Cl. Okay, so the general rule. The solute that dissolves to form the greater number of products or ions will have the greater freezing point depression. The freezing point will decrease by more, and the boiling point will increase also. So in this case, CaCl2, I will get Ca plus with a Cl minus and a Cl minus. Do you see that that's 1, 2, 3 moles of ions for every 1 mole I put in? So CaCl2 is even better than NaCl, but why won't we use that on our roads? Well, because it costs a lot more money. Okay. The normal freezing point depression for sodium chloride is -21. For CaCl2, it is -52, so it definitely does work better. The problem is I don't put calcium chloride on the roads because it's so much more expensive to make. We will see in lab, last year when we did this lab, about the best I got was -17 degrees Celsius, possibly -18 degrees Celsius. So we'll see what we get this year when we make our ice cream. Okay? So now we need to understand a little bit about freezing point, boiling point depression. I promise you it's not the biggest topic. The concentration pieces are much more important as far as this. But here we go. We can do practice packets 17 through 18. Now you are going to do your quiz prep for number 4, which is going to be mostly concentration with a little bit of this colligative properties in it. The quiz is called concentration colligative properties. Take your quiz when you're done with your quiz prep, and we are done with this part of the unit other than Pogles and quizzes and practice packets and all that good stuff. So you be well, study hard. See you guys tomorrow in school.